What's up, folks? Welcome back to Light Source Engraving. I'm your host, Patrick, as usual. And if it's your first time here, thank you so much for visiting. I greatly appreciate it. Now, today we don't have an engraving project per se, but we do have a project that needs done to make our engraving better. So I have a 150 millimeter lens that's new. I need to set up the profile in LightBurn for it. And I also need to switch back to EZcad so we can run the 9-point lens correction, or Corfile, as you'll hear it called. And then get that Corfile imported back into LightBurn, and then we'll be off and running with our new lens. Freshly calibrated and marking squares when we want squares and not oblong spheroids or footballs. So anyway, there's a few things you're going to need before we begin this process. You need something to measure with. Caliper, ruler. This is better. This isn't as accurate, but at least have something in millimeters. A piece of steel so we can find our focus for this 150 lens. And then for running our Corfile, I like buying the sheets of poster board at Dollar Tree for $1, and then just cutting them or ripping them into size. Or you can just get cardstock, but the black works best. It makes a nice white line on it. They're great for running your Corfiles and lens calibrations for LightBurn camera. But those are the only things we need hardware-wise. Software-wise, we'll get into uninstalling the LightBurn driver, installing EZcad driver if necessary, and then we'll just hop right into running our Corfile. But first, let's find the focus for our new 150 millimeter lens. Now, a 150 millimeter lens is an f210. So the first thing we want to do is make our lens approximately 210 millimeters above our surface to be engraved. So let's do that real quick. All right, so I'm going to be test marking on this piece of metal. So we want to be approximately 210 millimeters above it to the bottom of our lens. And I'm just going to eyeball it and bring it down to about 210. And there we go. So that is approximately where we need to be to run this lens focal test. Lens focal test is pretty simple. One thing I'm going to do for this lens focal test is to make a circle. And to make this easier for you guys to see, I'm going to change this back to regular mode, so uncheck dark background. So I'm going to make a circle, and then I'm just going to set this to run a speed, set it at fill. We'll run a speed of like 4,000. Power of 90. Frequency 50. Interval isn't critical. We'll make it 0.032. And Q pulse, I want it maxed out 500. And that will get us where we need to be. And then I'll just set this to run multiple times so we can adjust up and down and find our focus. I'm just going to hit start. And the only thing I'm going to do is move the laser head, the galvo, up and down until I'm at the loudest and brightest engrave. So move it up and down, find the space, and you'll notice when it starts to trail off, either up or down, get right in the middle of that, and you'll be at the ideal focal spot. Let's switch back to this camera, and I'm going to hit start. And you'll see right there we have hardly anything going on. So what we want to do is go up. And there, now we're getting some light. Then it trails off, bright. Trail off. There, it's bright. It starts to trail off again. So let's run that again. So approximately right there is our optimal focal distance. Now that we have our optimal focal distance, we can measure that and then make ourselves a focal stick so that we don't have to measure any longer. So hold on a moment. I'm going to measure that and put together a focal stick, and then I'll be right back with you. All right, folks, I'm back. I have my focal stick. Now, what I'm going to be using today is one of the focal sticks that I actually sell on my website. These are tongue and groove, so they lock together just enough that you can get your height worked out, and then you can put them together with hardware or super glue them in place. But I 3D print these out and sell them on my website, but I like using these. I have them everywhere. So the good thing about the tongue and groove is you can kind of lock it in place, and then if you need to, just kind of wiggle a little bit, slide it, and get it at the perfect height, then screw it together so it doesn't slide, or super glue it and it will never slide. So I'm going to show you right now with these focal sticks. All I have to do is I have my bottom one fastened. That is a little too high, so all I have to do is just see, I've got it tightened but not tight enough to where I can't move it, so I'll just slide it down a little bit. And then you can put this one up here, lock it in place. All right, I know right there's my perfect focal height. Then all I have to do is add my hardware. I just use 4mm bolts and 4mm nuts. And then what I will do is tighten these down. They don't have to be super tight. They tend to stay in place pretty well. But once you hear them crackling a little bit, then you'll know that they are locked in place. So now we have our focal stick. And so I don't get them confused, I always write what laser it's for. Monport 150mm. And now every time I need to get in focus, I've got a perfect focal stick. And that's all there is to it. So now we are in focus. We are ready to get EZcad set up and run our Corfile. If you have a CO2 or a UV laser, finding your focus is very much the same process, except instead of burning a big circle with your CO2 galvo, what you'll want to do is just run a line, adjust, run a line, adjust, and keep adjusting up and down until you get that line as thin as possible. When the line is as thin as you can get it, that's when you know you're in focus. With the UV, you can do that on wood and run the line, or you can do metal with a piece of scrap metal like we did on the fiber laser. So no matter what galvo you have, it's the same process, you just change your technique just a little bit. Okay, now what we need to do is go to our device manager. And under USB devices, we'll see the USB LMCV4. We need to get rid of this driver so that we go back to our EZcad driver. What we want to do is uninstall the device and then do attempt to remove the driver for this device. So again, you can just go to Device Manager, find the USB LMCV4 under Universal Serial Bus Devices, then uninstall, and then click the box to attempt to remove the driver, and then click uninstall. Now it should be going. Now we no longer see that device. Now, I just turned the laser on and off, and we do have the USB LMCV4 installed. So let's uninstall that device again and attempt to uninstall the driver. But if this happens, the thing to remember is turn off your device and then uninstall. Now that we have uninstalled that successfully, we no longer see it in universal serial bus devices when we turn the laser back on. Instead, we see it up here under BJJCZ device, laser mark control board. So that's what we want. So if you cannot get the driver to uninstall, turn your laser off while you have it selected, while that window pops up. Then it should be able, Windows should be able to uninstall the driver. This is the driver we wanted to see so that we can now use EZcad. Okay, now we need to navigate to your EZcad folder, whether that's on your USB drive or you've transferred it over to your hard drive. But inside the the EZcad folder, excuse me, we will have a program called Corfile 2, and this is what we want to run. So just double click that, and you'll get it in Chinese. We don't want that unless we speak Chinese or read it. So what we want is Corfile ENU, because that's going to be in English. I just wanted to show you that because there's two in there. You'll say, which one do I pick? ENU is the English version. So first we need to set our laser parameters. So IPG is fiber. This is where we set our frequency. I'm just going to set it at 50. Power analog output, we're just marking paper, so we don't need a lot of power. I'm going to leave it at 10% and see how it does. Mark speed, this shows up as bits per millisecond instead of millimeters per second, which is no problem. I'm going to leave it at 200 bits per millisecond, and if need be, we can run it twice. Test box size. This is how big of a square it's going to draw on your paper. I normally leave it at the default setting. If you find out that it's too big, you can reduce it down. If you find out that it seems too small for your lens size, you can always increase it. But start with the default and then proceed from there. Once you have your poster board or whatever you're engraving in place, then all we have to do is click the Mark 9 points box. It's very faint, so I'm going to go over it one more time. It could actually use to have a little bit more power. So I'm going to close that again and then Mark 9 point box. Now at this point, I do have a square that I can see. Let me show you that on the camera. All right, folks, at this point in time, I'm going to number these corners. So that we can see them. I want you to be able to see these boxes. Okay, folks, at this point in time, this is still in the laser bed, so I'm going to mark these intersecting points. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a welder's pencil, so it's silver and shows up really well on black background. Now, there are several ways you can do this. You can start measuring, write your measurements down, and then input them in EZcad, or you can input them as you are making your measurements. What I'm going to do is make my measurements and then write them down. So what we will need to do is measure from this outside here to the inside here. And then the same thing we'll be doing from this side. So we'll be getting these distances. And then we'll be getting the distance from the outside on the top and bottom. So here, here. And by measuring these distances and inputting them into EZcad, it will do a lens correction calibration for us to get rid of these curved lines that you see here. And one thing that we want to remember as we are measuring these is we want to measure point to point. So we want to measure point at which this crosses to point at which these lines cross. So we're always measuring point to point. So not point to line, it's point to point. So where the two lines cross. So I'm going to show you on screen what these boxes look like where we input our measurements. And then we'll come back here and I'll show you how to take those measurements. And then we'll measure them all and then input them. Okay, we're over here in EZcad. And what we have are 3 measurements for the top, 3 for the bottom in both sections on X and Y. That is because we will be measuring from point 1 to point 2. See, this is number 1, so it goes 1 to 2. This is number 3, so it goes 3 to 2. Number 4 goes 4 to 5. Number 6 goes 6 to 5. There's nothing for number 5 because you're not going to measure 5 to itself. So see how we're going down the x-axis? So then we go 7 to 8, and then 9 to 8. So that is our 7 and 9s. So then for our y's, we have 1 to 4, 2, so it'd be measurement 2, 2 to this center line, to that point. 3 goes 3 to 6. Then we don't have anything for 4, 5, and 6 because they're on the center line. Then we have 7, measurement 8, and measurement 9. And those are the 9 points that we need to complete our Corfile calibration. Now, something else we need to pay attention to is this diamond, this line, and this square. We need to make sure that this matches what was drawn by EZcad when it drew the square on our paper. And what I have on my screen matches exactly what is on the paper, so I don't have to change. But there is that option there to change the image. So if your image does not match what is drawn on your poster board, then you need to run through this change image process, and it will cycle through all the different variations, and you want to find the one that matches yours. So we had the diamond, the line, and the square. So the diamond's here, the line is above the center line, and the square down in the corner. That matches, so here's where our measurements are going to go. We're measuring these points, 1, 4, and 7 to the center line. 3, 6, and 9 to the center line. So we need the measurement of 1 to 2, 4 to 5, 7 to 8, 3 to 2, 6 to 5, and 9 to 8. Just like I drew the arrows on the screen. We will be measuring 1 to 4, 2 to 5, 3 to 6, 7 to 4, 8 to 5, and 9 to 6. So those are the measurements that we need. My pencil stands out really well, way better than the engraving. So again, like I said, it's point to point. So the point where the two lines touch. So this will be 69.05. Then we'll go from 2 to 3, 70.08. Then we need 4 to 5. 70.78. We need 7 to 8. 68.56. 8 to 9. So it really doesn't matter what order you measure these in, as long as you write it down and keep them straight. 69.57. 71.34. This one is 've already done that one. Looks like I'm getting a better measurement this time. 69.78. Let's cross that out. Now let's do our measurements for the Y. Again, we're going point to point. So here we have 72.11. 72.11. From 2 to 5. We have 71.50. And from 3. That's not right. I think my battery's going dead in my caliper. Hope we can get through this. 72.41. I only got 3 to go. This one is 72.69. 70.84. 73.16. Now we can take these measurements and input those into EZcad. Save our correct file. So that's saving our Corfile. I saved mine. So what I'm going to do is just save it to, I didn't mean to do that. I'm just going to save it to my desktop, and I'm going to call it Monport 150mm. So I know which laser and lens it is. Now we're going to do calibrate standard box. So what's going to happen is it's going to run a box of squares. But first I'm going to increase the power a bit. Let's make that 20 so we get a better mark. And then hit calibrate standard box. So flip your paper over to the other side and then hit F8, which is calibrate standard box. And it's going to make a nice big square for us so we can measure and make sure that we input our values correctly. So with your caliper out again, you'll notice the space between these boxes, or these lines, should run 5 millimeters. All right, so that's approximately, depending on which angle I'm looking at it, right about 5. So then I can compare this one. That is, all right. Camera's in the way and it's kind of hard looking off at an angle. All right, so I think that's correct. That one is correct. And correct. And then you want to just spot check all these just to make sure that they are all 5 millimeters. Then you can also measure between like lines and make sure that they're the proper distance between each other. So let's say we wanted to do the 1, 2, 3, fourth block out. That would be this one. I'm just going to make a mark so I know which one I'm going to measure. And then we're going to measure from box to box. And that is not 3 millimeters. Yep, I need a new battery. Well, just let me get one measurement here. All right, that's coming out 40.05, and I was probably a little bit off. And right there, 40.05. So we are definitely right on. I feel good after that spot check. It looks fairly square to me. So we're just going to roll with that. And then let's get back over to the computer. Okay, we're back at our PC. What we need to do now is install the USB driver for the control card. What we can do is go to Windows, C drive, then head to Program Files, head to the LightBurn folder, and wouldn't you know it, inside the LightBurn folder, there is a folder called EZcad 2 driver. This is the same driver that's installed whenever you install LightBurn. So if you still have your LightBurn install file, you can run it and then at the end choose to install the EZcad driver. If not, just double click on that. It will bring up the installation wizard. It will install the driver, and then you can just hit finish. And when you know it, we're right back to having our USB LMC V4 installed. We should be able to start up LightBurn, select our Monport laser, and found USB light. So there we go. We are ready to roll with our Corfile. So how do we use it? First thing I need to do is go to Devices, Monport 60 watt 200 millimeter. I'm going to export that. I'm going to export it to my LightBurn folder and settings, and Monport 200 millimeter. Whoops, sorry. I have a devices folder. There it is. So I'm going to do the Monport 200 millimeter and save. Then I'm going to import back to the LightBurn folder, devices, Monport 200 millimeter. Now we'll have that in there twice. Then I want to double click it and then just run through. I don't need to import it, it's already there. And this is Monport 150 millimeter. I'm gonna ignore this because we have a Corfile. Corfile is going to tell LightBurn what the X and Y lengths are. I'm gonna hit finish. Then what I want to do is scrub this up here and nest it with the other Monport. Then hit OK. Then from the drop down, I'm going to select the Monport, 150. I'm going to head to the wrench and screwdriver. This has the wrong Corfile in it, so I cleared that out, and I'm going to load the Corfile, which is on our desktop. And there's the Monport 150, and then hit OK, and that's it. So our Corfile has set our field size to 174, which is about right. You normally get about 10% extra added on to your field size from performing a Corfile at the very edges of your field size. If you are trying to engrave way out here, you could have some distortion. Sometimes it could even be cut off depending on your lens, but You just have to test and find out. That's the only way of really knowing. For example, on my 400 millimeter lens, it calibrates to about 440 millimeters, and I know I can stay within 430 millimeters and still get a good, consistent engraving out of that lens. So I gained 30 millimeters. Again, you just have to test and find out for yourself. Okay, we went through finding our focus, uninstalling the LightBurn drivers, the USB LMCV4 driver. We then were able to use EZcad and run the Corfile ENU, which is the English version. We got our boxes measured. We ran the calibration square. Everything looked good. And then we duplicated one of our lasers and then imported that Corfile into that particular laser. I think that pretty much covers the installation of a new lens. And if you don't have a device that you're going to duplicate, say you're not adding a second lens, but it's a new device and a new lens, all you have to do is just go to devices, click add new. It's a fiber. You set the field size, and your manufacturer should have gave you a configuration file that's on your EZcad, in your EZcad folder, and should have gave you instructions on how to do that. So you import the Mark CFG 7 file, I believe, into LightBurn, and that gets all your settings for your frequency and red dot and that kind of thing. But that is a basic run through of everything you need. If you have any questions, something I missed, leave me a comment down below and I will answer it and get you fixed up with an answer. But that's all. I appreciate everybody watching. I appreciate my patrons for making this channel possible and allowing me to buy these test material like the poster board and the glass and everything else I've been doing. But that's enough rambling for today. Everyone, I hope you have a great day, and I'll see you in the next one.